Okay, this should be our last review video for exam 3, and it covers questions 7, 8, 9, and 10, all of which come from section 3.4, present value of an annuity. And in our first question here, in question 7, we have an annuity that has a present value of $3,600, and the interest rate is 12%. It's compounded monthly, and we want to know how much monthly payments are going to be if they are distributed over a 4-year period. Well, the formula is right here. Payment equals principal value times I divided by 1 minus the quantity 1 plus I raised to the negative n being the total number of compounding periods, but it's negative in this case. So I've filled in the values here and made the calculations, and so that's $3,600 for present value $3,600, and the I is 0.01, so I put that in the numerator. In the denominator I have 1 minus 1 plus 0.01, and the exponent is negative n, which is the number of compounding periods per year, 12, times the number of years, 4, so this is 48. And you could simplify your calculations by adding 1 and 0.01 in your head. It's very simple. This is just going to be 1.01, and multiplying 12 times 4, so that's just 48, so that's simple too. And if you enter everything incorrectly, you'll get a payment amount of $94.80. Well, the keystrokes for that are very similar between the two calculators, but once again we have a small difference that that has to do with how this exponent key is read in the two different calculators. So I enter in 3,600 and then times, so there's a multiplication key, 0.01, and then divide, the division key, and that's this, 3,600 times 0.01, and then with a fraction, that fraction is from the division key. And then I have a left parenthesis here to segregate out the denominator. So here's where my denominator starts. I have a left parenthesis, 1 minus, so there's a subtraction key. And then I need another left parenthesis for the base of this exponential expression here. So I have a left parenthesis for that. And again, I could just type in 1.01, although I've typed 1 plus 0.01 here, and then I close my parentheses. This parenthesis right here corresponds to this keystroke, and then I need the exponent, so I press the little caret button that says exponent. And for the graphing, I need left parentheses right here before I type the negative sign key. Now, I'm sure you're aware of this, but I just want to emphasize this key here is subtraction. This is the sign change key, and it's at the very bottom of the keypad for every TI calculator I've ever seen. It's at the bottom of the very keypad next to the decimal point. So that's the negative sign, and then of course you multiply 12 times 4, and then you close that exponent with a right parenthesis here, and then you hit enter or equals. And to tell you the truth, I am not sure why exactly it does this, but I think that this will still give you the correct calculation even if you don't enter this last parenthesis in. It's very odd that it does that, but somehow I suppose the calculator knows your intention. It read your mind. Yeah. Anyway, So those keystrokes strokes should give you 94.80. If not, talk to me in class and we'll see what might be going wrong. But I've checked it over a couple of times. Now the scientific, and again I'm using the TI-30XS. And if you have a slightly different model, then there may be some minor difference, to some of these keystrokes. But everything is the same all the way up until the time we get to the exponent. And when you type the caret to get the exponent, it opens this superscript. It gives you a little data entry line that is up in the exponent. It's smaller, so the things you enter in there are sort of in a smaller font. Well, once you do that, once you press that key right there, then you don't need to open up any parentheses. The calculator knows that whatever you enter now is going to be confined to that exponent, and so you type the sign change, the negative key, and then 12 and times 4. And when you hit enter on this calculator, at this point, it definitely knows to close out the denominator, and it makes all the calculations in the correct order and gives you $94.80. So that's it for question 7. Now question 8 is a lot of algebra. There's not too much problem. There's not much of a problem with calculator entry, data entry. Your main challenge is algebraic here, and so in this question we have the present value of an ordinary annuity at $20,000, and we have payments of $500, and the interest rate is per compounding period is 1.75%. So that's the I. We're already given the I, and we're asked to find n, the number of compounding periods. The number of compounding periods. And so this is the formula for that, or this is the formula that I used. There's more than one way to represent the present value formula, but I chose this one. I don't know why. It seems simpler to me than the other form. If you want to use the other form, you certainly may. But these values here correspond to these labels here. Present value 20,000, payment 500. I right here is 0.0175 in both places, and then it's the n we don't know. So we need to solve for that, and to do that we're going to use properties of or a key property of logarithms to get that exponent out, to get that variable out of the exponent. And so I multiply both sides of this equation by I over PMT, and that cancels this I in the denominator multiplicatively, and the PMT in the denominator cancels this PMT effectively in the numerator, and then that leaves this numerator 1 minus the quantity 1 plus I raised to the negative n. And I have, in this case, what I've done is I've added this figure here, this expression here, 1 plus I to the negative n. I've added it to both sides of this equation, and I have subtracted PV times I over PMT from both sides of the equation to put my variable on the left side. It's not necessary, but that's what I've done. and all of the numerical calculations have taken place over here. Now you'll see that between this step and this, I went ahead and multiplied present value times I and divided by the number of payments, and that was a very simple number, 0.7. Nice tight number without a whole bunch of digits running out in the decimal. And I've also, see, I've represented the 1 plus I as 1.0175. And now I'm almost there. I'm almost there, but I need to, and one reason why I did this addition is to isolate the base. I've uncovered the base here. There's nothing multiplying, adding, or subtracting in front of the base here. And so I take the natural log of both sides of this equation. Now you might think, well, I've got a 1 minus some stuff here. That looks a little messy. It's okay. It's just a number, so you can take the natural log of it. In this case, we take the natural log of this base raised to this exponent, use the power property to bring that exponent around front of the expression, and then we divide both sides of the expression by the natural log of 1 plus I, and that puts all of this in the numerator, and the natural log of 1 plus I in the denominator. And then, of course, because this is negative, we multiply both sides by -1 or divide both sides by -1, however you want to look at it, and that puts the negative on this side of the equation. So now this solves for n, and this is the number that is going to give us the n. And entering that into the calculator is a snap, really. It's very easy. We have a negative sign here, and that's the negative sign on either your graphing or your scientific calculator. Then the natural log key, ln, that key, and then this value, 0.3. When you calculate PV times I over PMT and subtract it from 1. Remember, PVI over PMT was just 0.7. And you subtract that from 1, you get 0.3. And so you're taking the natural log of 0.3. And then in the denominator, you're taking the natural log of 1.0175. And and then so your next keystroke here, I should point out, when you type the natural log key, it automatically opens a left parenthesis here. I didn't write it down because it's not a keystroke, but it opens up a left parenthesis for you. You type in 0.3. You need to close that set of parentheses right here before you hit the divide key. And then when you type natural log again, you get a left parenthesis open. You type this number in, and you type a right parenthesis to close those parentheses. And you hit enter, and you should get 69.4. And there's some extra decimals, but that's the cleanly rounded figure that you need.